Assalamu alaikum. We are doing a revision class for our midterm syllabus. Our chapters are physical quantities, measurement, kinematics, projectile, and we have dynamics, in which we have Newton laws, and we have linear momentum, 2D momentum. These are the chapters. I'm starting my class with the first topic. Physical quantities. The purpose of this class is to make some conceptual revision. I'm not planning to do questions. The idea is not doing question. The plan is not to do any questions today. The main idea is to do some conceptual revision. The important topics, not everything, obviously. So look, physical quantities, when you start this chapter, the most important topic is base units. So there are 7 base units, out of which you have to learn 5 of them. And I hope you have learned those, like mass is in kg, length is in meter, etc. In base units, our main common topic is to see the units translation. For example, if F is equal to ma, force is in Newton, mass is in kg, and acceleration is equal to ms minus 2. This is how we put the base units to get the derived unit. The idea is simple कि देखो जब आप base unit रखोगे, so you have to remember कि base units are the simplified units. So you can derive any unit using the base units, and this is how we can identify a formula. कोई भी formula होगा उसमें आप base units put करो, और आप उसके बाद you can get the derived unit, like work is equal to F into D. So Joule is equal to Newton meter. In place of Newton, you can see from here, it's kg ms minus 2 into meter kg m square s minus 2. This is called work, and this is the translation of Joule. So base units, the majority questions on base units are actually a concept of substituting the 5 base units, and you can use them to derive any unit. We have some comparison questions also. We have some comparison question also. Or usme you can always find questions like where you have to find any unknown unit. For example, F is equal to KQ1 Q2 upon R square, and they can ask you to find the unknown constant K. When you get a question like that, you have to remember the class discussion, that you have to rearrange the equation and you have to make K the subject. Uske baad, you can always put the units and you can find the final answer. This is the discussion on base units. I had a discussion on this article that the purpose here, I'm not doing any questions today, as I mentioned. जो आज का हमने रखा हुआ है इसका मेन पर्पस ये है कि हम कुछ डिस्कशन जनरल थ्योरी पे कर लें। ये जो पहला चैप्टर है, आई एम मेकिंग जनरल आइडिया ऑफ द फर्स्ट चैप्टर। द फर्स्ट चैप्टर में जो पहली चीज थी वो बेस यूनिट है, जो हमने थोड़ा सा रिवाइज किया। उसके बाद द सेकंड फीचर वो है यूनिट कन्वर्जंस। यूनिट कन्वर्जंस बहुत अच्छे से याद होने चाहिए, स्पेशली द प्रीफिक्सेस। एंड in unit conversions, when you convert from a small to big, you have to divide. And when you convert big unit to small unit, you have to multiply. Unit conversion में there is another feature to recall, and these are the prefixes. इसमें दो तरह के होते हैं। एक तो वो होते हैं जो there are two types of prefixes, मैंने कहा था कि इनको याद कर लीजिएगा। एक तो वो होते हैं जो मैग्नीफाई करते हैं और दूसरे जो होते हैं वो डिमिनिश करते हैं। जो मैग्नीफाई करते हैं जैसे किलो है, मेगा है, गीगा है, और जो छोटा कर देते हैं वो मिली है और माइक्रो है, एटसेट्रा। So these are the important units. These are the important features of unit conversion. फिर इस चैप्टर में if we go forward in this chapter, इस चैप्टर में जो अगला फीचर है डिस्कशन का वो होता है वेक्टर्स का टॉपिक। Vectors is a very important topic of this chapter. There are two main concepts of vectors to come in the paper. एक कहलाता है addition of vector, which is resultant vector. Resultant vector can be done. One is called the parallelogram method, and the second is resolution method. Parallelogram method is applied for two vectors only. जो resolution method है, resolution method can be applied for multiple vectors. The actual method is called, जो इन सारे methods को deal करता है वो है head to tail method. Head to tail method का मतलब ये होता है when you join the vectors, like this is the first vector, this is the second vector. So if you join the open end like this red is called the resultant vector. So resultant vector is obtained by head to tail addition, head to tail combination. Resolution method is very important, and resolution method is something which comes every year. And if I recall that if you have a vector at an angle like this is angle theta, this is f, This is f cos theta if you make a cut on it, and this is f sine theta. This is how you resolve a vector in two components. One is called the horizontal component and the second is called the vertical component. So every vector has two components, horizontal and vertical components. So you resolve the vectors. The method I discussed was in parallelogram or in resolution. The main idea is to find the resultant vector. So you resolve all the vectors, you find the overall x value, overall y value. हमने इसमें सीखा था कि आपको you have to use a concept that x is equal to right minus left and y is equal to up minus down. Then the resultant vector is obtained by x square plus y square, and tan theta is equal to y upon x. देखो ये method था. This is the method. This is the method for solving and finding the resultant of vectors. Finding the resultant of vectors, two vectors, maybe more than two vectors. जो parallelogram method है, it is limited for two vectors. This is called resolution method. This was our chapter number 1. And I'm just revising important factors, important concepts of every chapter. Measurement. Measurement is our second chapter. The first topic in this chapter to discuss errors. There are two types of errors. One is called random error, and the second is called systematic errors. There are two types of error. One is called random error and second is called systematic error. दोनों में फर्क है. जो random errors हैं, these are the errors which are always changing. Like, for example, you have made some calculation error, some unit conversion error. तो ये random होते हैं, जो कि कोई भी number ले लें. Systematic क्या होते हैं? जैसे the errors which are constant in magnitude and direction. So these are the errors which are fixed. Systematic errors जो होते हैं वो fix होते हैं, and they are like your watch is 5 minutes ahead. So you always, whenever you read the watch, you will get an answer which is 5 minutes more. So this is called systematic error. जो systematic errors होते हैं वो fix होते हैं. फिर इस chapter में जो टॉपिक सबसे ज्यादा आता है वो है अनसर्टेनिटी. अनसर्टेनिटी क्या होता है? बेसिकली इट्स अ एरर on both sides of a reading. For example, you say x is equal to 20 plus minus 1. जैसे हम you people see in marking schemes, the answer is written like this, 20 plus minus 1. So this is an error which is on both sides of the actual value. So this is called uncertainty. Here one is the uncertainty. Uncertainty should always be given correct to one significant figures. I had explained that there are three types of uncertainties: absolute uncertainty, fractional uncertainty, and percentage uncertainty. So when you solve uncertainty topic, any question related to that, you have a absolute uncertainty, you have a fractional uncertainty, and you have a percentage uncertainty. So there are three types of uncertainties. When you solve a question. Ahmed, you can ask on the, if you have a question, you can ask on the mic always, or ask on the chat. जो क्वेश्चन है, the question, forces, density and pressure is completed. We have done all the topics of this chapter, but it's not coming in the midterm. We are giving the midterm exam till dynamics, till linear momentum, like till 2D momentum actually. Forces, density and pressure chapter is completed, but we are not testing it in midterm. I hope it's answered. Acha, when you deal with uncertainty questions, the first thing is necessary. जो सबसे पहली चीज होती है, that is how we should able to break a formula. For example, it is V is equal to IR. मैंने इसके कुछ फॉर्मूलाज बताए थे. डेबा V अपॉन V is equal to प्लस माइनस डेबा I अपॉन I प्लस डेबा R अपॉन R. ये है अनसर्टेनिटी को लिखने का तरीका. यू राइट डाउन ऑल द वैल्यूज इन फ्रैक्शन. अगर ये परसेंटेज है तो आप यहां पर परसेंटेज का साइन लगा दो और इनटू कर दो 100 के. राइट? और अगर परसेंटेज नहीं है तो यू कैन लीव इट लाइक दैट. अनसर्टेनिटी के क्वेश्चंस में यू ऑलवेज हैव टू रिमेंबर दैट देयर आर सम फॉर्मूलाज टू रिमेंबर. Uncertainties are never subtracted. They can be added in fractions. और अगर कोई पावर हो like area is equal to L square है, so when you make the uncertainty it will be plus minus 2 times delta L upon L. This is the idea of uncertainty. So when you have some two functions being added or subtracted, their uncertainties are always added. When there is a product form, multiply or division, you have to add up the uncertainty fractions. When there is a power, the power will come in multiplication. So in chapter 2, uncertainty is the most important topic. Uncertainty is the most important topic. Then I come to the title of kinematics. Look, in kinematics, there are some important definitions. The most important is the definition of velocity and acceleration. Velocity is the rate of change of velocity is the rate of change of displacement. And what is acceleration? Acceleration is the rate of change of velocity. Velocity is the rate of change of displacement, and acceleration is the rate of change of displacement. After that, this chapter has some important equations of motion. Equations of motion involve S is equal to ut plus half at square, v is equal to u plus at, and 2as is equal to v square minus u square. These are called equations of motion. Then equations of motion are applied when acceleration is, we apply these equations when acceleration is uniform. So these are equations of motion, the three important equations of motion. Here in this chapter, we have sketches. Ab sketches alag se I have always told you people that you should learn the basic rules. Whenever you are dealing with sketches, the first thing people should always remember is the gradient. Gradient is equal to y upon x. The second thing is the area, which is equal to x into y. So when you find the gradient, whenever you find the gradient, it is ratio y upon x. And when you find the area, it is always the product of the two axes. It is always the product of the two axes. We have distance time sketches and we have velocity time sketches. देखो जो important चीज है वो इस तरह है कि अगर if you have a line straight going upward and it's a distance time sketch, then it means that line is straight, so gradient is constant. So when you find the gradient, it will show uniform velocity because gradient is constant. If you have velocity against time and you draw a straight line, it is a straight line, but this time the straight line means uniform acceleration. Why it means uniform acceleration? Because it's a straight line. Straight line means constant gradient. अब इस तरह अगर आप sketches को करोगे तो आपको रटना नहीं पड़ेगा. I put another example. I draw this line and I make a curve. इस कर्व का मतलब क्या है? ग्रेडियंट इज इंक्रीजिंग. अगर मैं लिख दूं डिस्टेंस अगेंस्ट टाइम, सो इट मींस वेलोसिटी इज इंक्रीजिंग. इफ आई पुट लाइक this velocity against time and I draw a curve, so it means now I will say that acceleration is increasing. This is the discussion on sketches. And when you come for area, when you talk about area, look, area is always the shape. Like for example, this is a trapezium. So when you find this area using trigonometry or using maths mensuration, the area will show, in this case, area will show distance. Why area will show distance? Because velocity into time is always acceleration. So these are the important concepts related with related with kinematics. Now I talk about projectile. Projectile, the first concept here, projectile is an example of a two-dimension motion. This is a trajectory of a projectile like this. When you launch a projectile, this is velocity, this is theta, and you make a cut. So here it is v cos theta, and here it is v sine theta. When you launch a projectile, this is the maximum point, and this is the trajectory of the projectile. In a projectile motion, we assume that air resistance is neglected. This is an assumption. We assume that there is no air resistance. So as a projectile move forward, we move forward, the horizontal component of velocity, which is Vx, it doesn't change. Vy decreases. At the highest point when we reach, The x component is still there, but y component becomes 0 when the projectile is going downward like this. This is Vx, this is Vy, and this is V. So here the projectile is showing, the horizontal component. Horizontal component does not change throughout the motion. In a projectile, full projectile motion, acceleration is taken to be negative g. Now, for a horizontal motion, when you are dealing with a horizontal motion of projectile, when you deal with horizontal dimension, you have only one formula, distance. For horizontal dimension, there is only one formula, dx is equal to vx into t. That is v cos theta into t. While for how we solve vertical motion, vertical dimension, the upward and downward motion, when you solve vertical dimension, you can use all the equations of motion. So for vertical dimension, you can use all the equations of motion which we have discussed in the in the previous slide. So these are called the two dimensions in a projectile motion. Air resistance is neglected. Acceleration remains constant throughout the motion. Velocity is resolved. Displacement is resolved. There are two acceleration. Horizontal acceleration is g, and vertical acceleration is g, and there is no horizontal acceleration in the motion. While the time is the only factor which does not resolve. So the time is not resolved. So time is absolute. Time is absolute in this motion. Time, if you calculate time for horizontal motion, you can use it for vertical motion too. Now, I move to my next topic after this quick revision of this chapter. Then I am in dynamics. Dynamics has two main topics. The first topic is Newton laws. Dynamics में जो पहला topic है, that is, there are two topics in this chapter. One is Newton laws and the second is linear momentum. Newton laws are, if we talk about the most important one, is Newton second law. The most important is Newton second law, which says F is equal to ma. F का मतलब है यहाँ resultant force. Now we have a formula which is very important to remember. Resultant force is equal to greater force minus smaller force. Resultant force is equal to ma. And how we find resultant force? Resultant force is greater force minus smaller force. So Newton laws, among the Newton laws, second law is the most important, which says that you can find the resultant force using the approach greater force minus smaller force. Newton laws are used to calculate acceleration. There are multiple cases I have discussed with you people, and I quickly recall the most important cases are like projectile, when, like inclined plane. When you put something on an inclined plane, you see the weight is acting downward. So you have to resolve the weight, like this is the line and you make a theta here. So you will get mg cos theta, and here you will write mg sine theta. Here it is r. This is inclined plane. We have another case that one object is on a table and we have a pulley and one object is hanging. We have a pulley like this and two objects are hanging from the inclined plane, from the pulley. What I have taught you people here, that look, whenever you are dealing with these type of questions, you always have to remember that when you are dealing with forces, any question like forces, there are always two options. One, the question is on resultant force, the first option. And the second option is that the question is on equilibrium. Resultant force I have discussed today in the start of this class. Equilibrium, when you say it is equilibrium, you have to use the logic right is equal to left and up is equal to down. This is the logic of equilibrium. Equilibrium means acceleration is equal to zero. Resultant force means acceleration is not equal to zero. So any case, when it comes to you, whenever you are dealing with any question in forces, you have to remember that the question is either on resultant force or the question is on equilibrium, which is the zero acceleration case. So when you come across a question, any situation, you have to apply these questions. Some basic energy formulas like kinetic energy is equal to half mv square and potential energy is equal to mgh. They also come in your syllabus. And even though they are in a separate chapter, but they are so general formula, so they can come in any section. Kinetic energy is equal to half mv square and potential energy is equal to mgh. Then we talk about linear momentum, a very important topic. Momentum is defined as the product of mass and velocity. Momentum is defined as a product of mass and velocity. The formula is m into v, product of mass and velocity, m into v, and the unit is kg ms minus 1. Momentum is a vector quantity. Momentum is a vector quantity and it takes the direction of velocity. Momentum is actually a measure of inertia. When two objects, two things collide, like a ball collides with a wall, then momentum is observed. Momentum is a measure of inertia. When momentum changes, suppose that an object is moving at u and velocity becomes v, then momentum changes and we call it impulse, m into v minus u, and this feature is called impulse. So momentum has a formula. Momentum has a formula. Momentum has a impulse. Impulse means change in momentum. Then something which comes in every paper is the law of conservation of linear momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. This is a formula for the law of conservation of momentum. This formula can be used. This formula can be used to deal with those questions which involve collision. So suppose there are two balls, A and B, moving on a track. They're moving towards each other. They collide and they go back like this. this is a collision. This is a collision between two balls and objects rebound. This is called law of conservation of momentum. Then in this chapter, we have a concept of collisions. There are two types of collisions: elastic and inelastic. So there are two types of collision. One is called elastic and second is called inelastic. So there are two collisions, elastic collision and inelastic collisions. You always have to differentiate between them. You always have to make a difference between them. If energy, kinetic energy, and momentum all are conserved, this is an elastic collision, like gas molecules collide. If momentum is conserved, kinetic energy is not conserved, then collision is inelastic. When collision is elastic, total kinetic energy before collision is equal to total kinetic energy after collision. This is the difference between elastic and inelastic. Then we have the concept of coalescence. What is coalescence? That when two objects collide, they are going like this. Two objects are going like this and they collide and they merge. They stick together and they are going together. This is called coalescence. In coalescence, the objects collide, they merge, and they go together. This is called coalescence. So coalescence is actually a concept of moving together. So then you have a formula M1U1 plus M2U2 is equal to M1 plus M2 into V, like this. So this is called coalescence, when two objects collide and they move together. 2D momentum is the last discussion point, and 2D momentum actually means that when objects collide in two dimensions, two objects collide, and suppose that one is disk A and this is disk B and it's coming like this. After collision, suppose A goes down and B go up. This is called 2D momentum. How we solve a question, I have shared two videos on it. Actually, this is a difficult topic always, that when you are dealing with a 2D momentum, remember to resolve the velocities of the two objects when they are moving in two directions. You have to resolve like this. You have to resolve the two velocities and then you have to apply the law of conservation of momentum. I mean the formula M1U1 plus M2U2 is equal to M1V1 plus M2V2. You have to apply this formula twice, once for y-axis and once for x-axis. You have to apply this formula two times, one for x-axis and one for y-axis, and then after that, you can solve the two equations to get the final answer. 2D momentum means that you have to actually solve the question two times in a way. Once you have to solve it for x-axis and then you have to solve it for y-axis. This is the main difference, and that is why this topic becomes difficult, because this is not solved by one equation. This is actually solved by two equations. So this is a quick revision of our syllabus, which is coming in the midterm. And if you people have any query regarding the exam tomorrow, you people can ask before I finish the class. You people have any query, you please can go ask it. In the end of the class, we have discussed triangle method also. This is used when three forces are applying on one point. The forces are in equilibrium. you will be given a diagram of forces. You are supposed to break the force diagram, join them head to tail, get a triangle. Once you get a triangle, you can solve it by trigonometry, O-level maths, and you can get the answer. You people can please read it, and you people have any query, you can ask. Even you can ask after the class also if you have any understanding issue.